Hi, so let's discuss the last video of stats, normal distribution curve. So normal distribution curve basically is also called bell curve. All of this is not important, is continuous probability distribution. What's important is it's like a bell shaped and it is symmetric around its mean. What does this mean is that if this is the mean of the bell curve, all the terms are equally distributed around the mean. That is what is a normal distribution curve. Normal distribution curve means the terms are equally distributed or dispersed around the mean value. Yeah, it is characterized bell shape, we have seen, with highest point at the mean. So this point is the mean. Mean we denote by m, and its tails extending indefinitely. There is no end. Okay. So something like this is the normal distribution curve. Now, the normal distribution curve is identified by intervals of standard deviation, one standard deviation. That means if I say this is mean, the next interval, how x-axis is designated by the integers. If this is 0, the next one you mark is 1. So in bell curve, the next point is marked by deviation, 1 deviation. So if I add 1d, this point becomes m plus d, and the next point becomes m plus d plus d. If I come to left, I have to subtract deviations and subtract one more deviation. Okay. Now let's come to the diagram. So this is how it's going to be infinite, like this, indefinite. Now what are these values? We have seen these are the points designated by one standard deviation of that set, whatever is the set. This 34% says that from mean to the next point, mean plus deviation, 34% of the terms of this set lies. 34% of terms of this set lie between mean and the first standard deviation. Okay, this is first, this is second standard deviation, right? The same to the left hand side also. Okay, not exactly first standard deviation, let me not put it like this. First standard deviation to the right, because it might, if I say first standard deviation, it will be 34 plus 34, right? From mean, first standard deviation is to the left and to the right also. So let me be more specific. Now these values are constant, they are not going to change for any set. For every set which follows normal distribution curve, these values are same. So you are expected to remember. Now as you can understand, this is the mean, so 50% lies to the right and 50% lies to the left, because it is symmetric about the mean. So as you can add, 34 plus 14, 48, and from second deviation to the right it is 2%. So questions are asked directly on this. Let's say given mean height of 1000 animals, they have taken set of 1000 animals and measured their height, and mean height came to 60 centimeters and standard deviation is 10. If the data is normally distributed, this has to be given, otherwise you cannot apply this, right? How many animals have height between this? So first thing is we will write, okay, so m is 60, d is 10. So if I have to plot, m is 60, so to the right it's going to be, because this is 10, so this is 70, this is 80, to the left this is 50, and One deviation left, this is 40. How many have height between 70 and 80? In a normal distribution, the percentage remains constant. So between 70 and 80, 14% of 1000 lie is 14 upon 100 multiplied by 1000, which is 140 animals have heights between 70 and 80 centimeters as per the normal distribution curve. So the questions will be mostly asked on the percentages. Okay, so I hope the concept of normal distribution curve is clear, and I'll see you in the next video. That is the end of stats for the exam. Thank you.